Solving rational equations. This video will help you review the LCD method for clearing fractions out of an equation, and then build this skill up so you can solve all types of rational equations. Reviewing the LCD method. Let's take a look at some definitions. The least common denominator, or often abbreviated LCD, of two or more fractions is the smallest multiple the denominators have in common. You should be familiar with the LCD. We always use the LCD when we're finding the common denominator of two fractions so that we could add or subtract them. The LCD method is a process where we multiply an equation by the least common denominator of the fractions it contains to clear all of the fractions out of an equation. Now let's take a look at an example that will help you understand how to use the LCD method to clear fractions out of an equation. So example 1, we're asked to solve this equation, and this equation has two fractions in it. And so the first step I want to do is I want to find the LCD so that I can multiply by it. So I look at my fractions, I look at the denominators here. I have a denominator of 12, a denominator of 3. The least common denominator of those two denominators is going to be 12. So now normally when we found a common denominator like this, we would build these fractions up so they had that common denominator. We're not going to do that here with this equation. All I want to do now is simply multiply both sides of this equation by 12. Okay, so I have myself set up here. I've rewritten the equation, and I'm multiplying both sides of this equation by 12 now. Remember, if I multiply both sides of an equation by the same number, I maintain the equality. So now I'm just going to go through and multiply by 12. So let's see, I would distribute the 12 on the left side. So I take 12 times the first term. Notice too, I've written 12 over 1. Since I'm dealing with fractions, it's going to be a lot easier to write this LCD over 1. So okay, so I multiply this 12 over 1 times x over 12. That's going to give me 12x over 12. When I go to multiply by this 5, I'm going to think of this as just a 12. There's no reason to think of this as 12 over 1 here. So I'll just take 12 times 5, which will give me 60. On the right side, 12 times 4 gives me 48. 3 times 1 gives me 3. Now I'm going to simplify each of these fractions, and as I simplify them, the fractions are going to drop out entirely. 12x over 12, well, that's just x. So on the left side, I'm left with x plus 60. 48 over 3, if I divide 48 by 3, I'm going to get 16. Notice now all the fractions are gone, and I'm left with one simple step to solve this equation. So I'd minus 60 on each side. So when I do that subtraction, I'll see that x is equal to 44. Now, leaving this LCD as a whole number 12 is a good technique when we're multiplying with just numbers. However, when we get to multiplying by polynomials, it's going to save us a lot of work as if we think about this 12 as being factored. So let me show you kind of another step here that makes this process shorter. On the left side, I'm still going to be multiplying by 12 over 1. The reason I'm doing this is because my only denominator there was 12. And what I want to do is I want to simplify here before I multiply. So on the left side, I can just easily divide the 12 out before I ever multiply and go straight to this answer of x. Now I would have to remember that that 12 has not been divided out in the second term, and I'd still have to multiply that term times 12. But essentially here I've gone and skipped the middle step and gone directly down here to kind of our simplified equation. Let's take a look at the right side now. On the right side I had 4 over 3. So I don't want to write a 12 here. I want to factor this 12 out, and I'll write this 12 as 4 times 3. The reason I'm factoring it out is I can divide out this common factor of 3 before I ever multiply. So I'm dividing out this common factor of 3 first, and I'm left with 4 times 4, or 16. So this is what we want to do when we get polynomials involved, which we're going to do in a second. And the reason that we're doing this is just to save us a lot of work of multiplication so that we can go straight down to this simplified form of our equation where there aren't any fractions in it. Now it's time to check your understanding of using the LCD method to clear the fractions out of an equation. Go ahead and pause your video player now and answer this practice question. As you're working this, try to use the factored form. You notice our denominator, LCD here, is going to be 15. But we want to write that 15 as 5 times 3 when we go to multiply so that we can kind of clear or simplify these fractions as we're multiplying. Go ahead and practice that. That step is going to be key when we start to get polynomials involved. Okay, so I've rewritten the equation. We are going to multiply by this LCD. But instead of writing 15 over 1, I'm going to think of this 15 as 3 times 5 on both sides here. Okay, that's still multiplying by 15, but watch, it's going to make it much easier here as we go. So now when I distribute to the first term there, notice we're multiplying by 15 and then dividing by 15. This denominator or common factor of 15 is going to divide out of both the top and the bottom there, and we're going to be left with just x. Now when I go to multiply by my second term, you can easily see that that common factor of 5 is going to divide out here and leave us with 3 times negative x, or just minus 3x there. On the right side, the common factor of 3 is dividing out, leaving us with 5 times 1, or just 5. So now I've cleared all the fractions out kind of in one step, simplifying as I multiply. Now I have this simple equation left to solve. Let's see, x minus 3x is going to give us negative 2x. That's going to be equal to 5. Divide both sides by negative 2. And we're left with x equals negative 5 halves. Now we're going to extend the ideas of using the LCD method to solve equations with fractions in it to now solve some rational equations. So let's first start with a definition. A rational equation is simply an equation that contains at least one fraction. So congratulations, you just in that last practice problem here solved a rational equation. That was the problem we just did in that last question. Now I'm kind of calling that a level 1 rational expression because here we have all of our denominators are just numbers. We have some variables in the mix, but here our denominators are just numbers. Also, every one of these terms is just a monomial term. So all we're going to do now in this video is kind of ramp this level of difficulty up here so that we can get some more complicated rational expressions. So here's kind of a level 2 rational expression. Notice we have some binomials now in our numerator, which kind of complicates things. Not a whole lot, but a little bit. And then finally we're going to kind of ramp this up to a level 3 rational expression, and we'll be solving these in the video. And now notice I have binomials in both the numerator and denominator, and this equation looks very complicated and difficult. But what's going to happen here is we're going to use this LCD method to clear all of these fractions out of here, and it's going to make this equation a lot easier to solve. All right, let's take a look now at an example where we're kind of ramping this up to a level 2 rational expression. We're going to follow the exact same procedure as we did before. Things are just going to get a little bit more complicated because now we have binomials in our numerators up here. But let's take a look. Still the same process. First we look at all of our denominators, find the LCD. So denominators of 2, 9, and 18. The least common denominator of those would just be 18. So I'm going to go through and multiply both sides of this equation by 18. Okay, so I've set myself up here. I've rewritten the equation, and I've multiplied both sides of this equation by 18. However, I'm going to work a little smarter here on the left side and not write that 18 as 18. I'm going to write it as 2 times 9, because notice my denominators are 2 and 9 here. And I want to divide those out before I ever do any multiplication. Notice if I did the multiplication here, I would be multiplying by these binomials in the numerator, and that is really going to get complicated and messy. So I'm going to divide these things out as I'm going. Let's go ahead and do that now. So I'll distribute this 18, and notice the first time I distribute it, this common factor of 2 is going to divide out. So a 2 is going to divide out of both the numerator and denominator. I'm not going to divide it out over here because I need it in the next one, but the 2's are going to divide out and leave us with basically this, 9 times that numerator, which was x minus 5. Let's go ahead and distribute to the second term. Here the 9 is going to divide out, and I'm going to be left with this, that minus sign there. But now 2 is going to just be all that's left we're multiplying by, so I'm going to have 2 times x minus 5. On the right side, notice I've written 18 as 18 because I want to divide out this common factor of 18 before I ever start multiplying. And notice there we're just left with 7. So by dividing these factors out as I've gone, I've really simplified this problem. All the fractions are gone. All I have is a very simple equation to solve. So I would distribute my 9, which would give me 9x minus 45. Distribute now a negative 2, which would give me negative 2x plus 10. Let's see, combine our like terms here. 9x and minus 2x is going to give us 7x. And then negative 45 plus positive 10 is going to give us negative 35 equals 7. All right, add 35 to both sides. Looks like we're going to get 7x equals 42, and when we divide both sides by 7, we're going to get our final answer that x is equal to 6. All right, let's go ahead and check your understanding now of solving these level 2 rational expressions. So go ahead and pause your video player and answer this question. However, before we start here, notice I've kind of thrown you a little curveball where x is involved in this denominator. All we have to do really is basically include that. So find the LCD of the numbers and then just include an x on the end there, and that will be your LCD. So go ahead and pause your video player now and answer this question. All right, let's take a look. So first let's start with our LCD. Let's start with our numbers. 2, 9, 18, and 3. Well, that's still going to be 18. All of those numbers would go into 18, or that would be a common multiple for all of those numbers. So that's the number part. Now we just want to include an x on there. And so there's our LCD, 18x. Okay, now I've set myself up. But notice on the left side of the equation, here are the things I wanted to divide out. I wanted to divide out a 2x, and I wanted to divide out a 9. So I wrote the LCD 18x as 2 times 9 times x. Let's go ahead through and multiply by this now and watch these things clear out. So when I distribute to the first term, notice both the 2 and the x are going to divide out. So when the 2 and x divide out, they're going to divide it up here as well. All I'm going to be left with is a 9. So all I'm going to have there is just 9 times 5, or 45. Let's go to the second term. Here, that common factor of 9 is going to divide out, which leaves me all left to multiply by is just a 2 and an x. So 2x times 8 is going to give me 16x. Let's take a look at the right side now. Notice here I wanted to divide out an 18 and a 3x. So I wrote 18x as 3 times 6 times x. Let's go ahead and multiply by it. So when I multiply by the first term, notice I'm going to think of this as 18. 3 times 6 is 18, which is going to divide that 18 out, and all I have left is x times 1 to give me x. When I multiply by the next term, the 3 and the x are going to divide out, which leaves me now with just a 6 to multiply by, so I'm going to have minus 6. So notice in that one step there, I've taken a very complicated equation and simplified it down to this quite simple equation. I have variables on both sides, so I would get rid of or remove the smaller term, which means this negative 16 is going to go away, so I would add 16x to both sides. Let's take a look. So that would leave me with 45 on the left side, and then I would have 17x minus 6. Add 6 to both sides. Looks like 51 equals 17x. Divide both sides by 17. And I think that 17 goes into 51 3 times, so our solution there is going to be just x equals 3. So now let's take a look at an example at a level 3. We've got some binomials in here in both the numerator and denominator. This looks like a very complicated equation, but it won't be if we can clear all the fractions out. Now if you've been watching the video and it looks like it's so much easier for me to do these problems, the reason that's happening is because I'm thinking of these factors and dividing them out as I multiply. You really need to practice this, even if it's kind of tricky or difficult at this level. You really need to get a handle on dividing those factors out as you multiply. It's going to make this whole process a lot easier. Another thing now, once we get binomials in the denominator, we're also going to have to factor them first to find the LCD. It's going to be a little bit harder here to find the LCD. So let's take a look. I'm going to come over here and I'm finding the LCD. So I'm going to look at just these denominators. I won't worry about the numerators at this point. I have these 3 terms and I'm going to factor these. So first I'll factor this 2y plus 2. When I factor that, that's going to be 2 times y plus 1. When I factor the next one, I'm going to factor a 4 out of that, so that would be 4 times y plus 1. The last one is just y plus 1. So what I want to do is I want to represent each of these factors. So let's see. They all share a common factor of y plus 1, so that's going to be part of our denominator. So for sure I need that. Now let's look at our numbers there that are kind of involved. I have a 2 and I have a 4. The LCD of 2 and 4 would just be 4. So this is going to be the LCD for this entire thing. 4 times y plus 1. Now let's try to divide these factors out as we're multiplying. So I'm going to multiply here by the first term. Let's see what we can divide out before we multiply. Well, for sure the y plus 1 is going to divide out. That's no problem. So the y plus 1 is dividing out here. This one as well. I won't cross it out because I need it for the next term. But the y plus 1 is going to divide out. Now let's take a look at the 2 and the 4. Notice a common factor of 2 could divide out there before we ever multiplied. If I divide this common factor of 2 out, all that's going to leave me with is a 2 up here. So essentially, all I need to multiply after everything divides out, all I need to multiply times this y is just 2, which is going to give me 2y. Now let's go ahead and multiply it by the second term. Notice they match identically. 4 times y plus 1, 4 times y plus 1. All of those factors are going to divide out, and all that's going to leave me with now is the numerator essentially getting multiplied by 1. So there's no change there. It's going to be this, minus 2y minus 16. Now the reason I put the parentheses around there is this subtraction symbol is saying subtract everything up here, not just part of this. So I needed to put a parentheses on there to make sure I'm subtracting both of those terms. Okay, on the right side, you can see that our y plus 1 is going to divide out, and all we need to do now is multiply that y minus 3 times 4. So I've multiplied by the LCD, and I've simplified my equation tremendously here. So let's start with the left side. We'll simplify this. 2y minus 2y is going to give me 0. Now when I distribute this negative sign to the negative 16, it's actually going to become positive 16. On the right side, I have 4y minus 12. Now just a couple steps away from solving this problem. Add 12, and it looks like we'll come over here to finish this. 1828 is equal to 4y. Divide both sides by 4. And we see that I get a final answer that y is equal to 7. Now it's time to practice this level 3 rational equation. Go ahead and pause your video player and answer this question. When you get done, hit play to see how you did. Remember that we're going to have to factor these denominators first before we'll be able to find that LCD. Alright, let's take a look. First thing we're doing is we're finding this LCD. So we want to look at all of these denominators factored. The first one is just x plus 3. That's what I have in that first denominator. The second one is just x minus 2. The third one, my third denominator there, if I go ahead and factor that, that's going to factor into x plus 3, x minus 2. So there's my third denominator. So the LCD is just going to be x plus 3 times x minus 2. You know, if we simply multiply these first two together, that's what we get. So our LCD is just x plus 3, x minus 2. And so that's what we want to go ahead and multiply both sides of the equation by. Okay, so I've set myself up here. Notice I factored the denominators in the original equation. I came up here, and if these two terms were written like this, I went ahead and put parentheses around them so I could think of them as a factor. I did that in both of these cases. And then that final denominator, I went ahead and left it factored as x plus 3, x minus 2. Okay, let's go ahead and multiply now. So when I distribute this to the first term, notice the x plus 3 is going to divide out. So that x plus 3 is going to divide out entirely, and all I'm going to have left then is 6 times x minus 2. Bring my minus sign along now. When I distribute to the next term, notice my x minus 2 is going to drop out. So I'll have this minus 5 then times all I have left to multiply by then is this x plus 3. On the right side, notice the x plus 3 and the x minus 2 are going to divide out entirely. So all I'm left with on the right side is just 20. Now I've got a nice simple equation that I can solve. Distribute the 6. 6x minus 12. Distribute the negative 5. Negative 5x minus 15 equals 20. Let's simplify that left side. 6x minus 5x is going to give us x. And then negative 12 minus 15 is going to give us a negative 27. Then we just add 27 to both sides. Kind of come over here. Let's see. X is then going to equal 47. All right, let's go ahead and practice another one. You may not be experiencing total success yet at this point, and that's fine. I mean, this is a complex process here, and it's going to take a couple times. So don't get discouraged. Go ahead and keep practicing this. It's going to come together. So go ahead and pause your video player, practice this one again, and then hit play to see how you did. All right, let's start with our LCD. We'll look at our denominators in factored form. So my first denominator, I can't factor that. It's just 2x plus 3. And then my second denominator, I can't factor that. So it's simply x minus 2. Well, they don't share any common factors at all, so really the LCD is just going to be these two things multiplied together. So my LCD here is going to be 2x plus 3 times x minus 2. And that's what I want to go through and multiply by. If you were not able to find this LCD, or you found something else, and that's going to totally mess your problem up from here, go ahead now and pause your video player and use this LCD that I found right here to work the rest of the problem. If you've got this LCD, keep watching and make sure you're doing the rest of the problem right. Okay, I've set myself up. I multiplied both sides of the equation by our LCD, this 2x plus 3 times x minus 2. So let's go ahead on the left side and multiply. Notice when we multiply on the left side, we're just multiplying by this one term here, two terms here. So we're going to need to distribute, but we'll get to that in a second. First, let's look at what's going to divide out. Notice the common factor of 2x plus 3 is going to divide right out for us. And all that we're going to have left then is to multiply these two binomials. So on the left side I have this, x minus 2 times x minus 1. On the right side, here my x minus 2 is going to divide out, and so I'll have left 6 times 2x plus 3 left to multiply. Okay, let's go ahead and multiply each of these sides together. On the left side, when I multiply x minus 2 times x plus 1, that's going to give me x squared minus 3x plus 2. On the right side, I'm going to have 12x plus 18. All right, so I have like terms, but also notice this. I have a squared term in here. This is not a regular equation that we're used to solving. This is actually a quadratic equation. The way that we solve quadratic equations is get everything to one side and 0 to the other. So I'm going to try to get 0 over here on this side. So I'm going to subtract 12x and subtract 18. So we kind of had to shift gears there a little bit because of that squared. And if you didn't recognize that, that's fine. This is just practice. That's how we start to learn these things. So I'm subtracting 12x and negative 18 from both sides. So here's where I'm going to subtract my 12x, and here's where I'm going to subtract my 18. We'll kind of come over here to finish up. So let's take a look. On the left side of the equation now, I'd have this x squared minus 15x, and then minus 16. On the right side of the equation now I have 0, which is what I want. So now what I'm going to try to do is factor this left side and hopefully find some zeros here. So let's see, we need x and x. Last term is negative, so that means my signs need to be plus minus. And let's see, 16 and 1 I think is what's going to work. 16 here, 1 there. It factored, so now I'm going to go ahead and find my two solutions. The first one, the way I could make this first factor equal to 0 is if x equals negative 1. Second factor is if x is equal to positive 16. So if you got this one, you recognized it was a quadratic equation and solved it correctly, fantastic. If you didn't get it and you kind of got muddled at the end there, that's just because you hadn't seen it in a while. So now you've seen it, so now when you'll see it in the future, you'll be able to solve it. All right, let's practice another one. Go ahead and pause your video player. Multiply by the LCD to clear the fractions out of this thing. When you're done, hit play to see how you did. All right, let's start by finding the LCD. Well, we have two fractions here, x minus 1 and x, and they don't share any common factors. Remember, we want to think of this first denominator as an entire factor. So that denominator is x minus 1, the other denominator is x, so they really don't share any common factors here. So our LCD is simply going to be x times x minus 1. And that's what we're going to want to multiply both sides of this equation by. Okay, so I've rewritten my equation. I'm multiplying both sides by our LCD, which is x times x minus 1. Let's go ahead and multiply on the left side. When I distribute that in, notice the x minus 1s are going to divide right out for me and leave me with just x times 3, which is just 3x. Now when I go and multiply by the second term, notice the x's will divide out, so I'm left with x minus 1 still to multiply by. So that's going to be 8 times then x minus 1 was the last thing that I had left to multiply by. On the right side, nothing at all is going to divide out. In fact, there's really not a lot of reason to think of this as a fraction. we could really just think of this as x times x minus 1. Nothing's going to divide out, so we simply need to multiply this 3 times that x. So we get this, 3x times x minus 1 on the right side. All right, let's go ahead and simplify each of these sides. The left side, let's say we have 3x, distribute the 8. All right, let's distribute the 8. So 8 times x will give us 8x, and then 8 times negative 1 will give us negative 8. On the right side, we'll distribute the 3x. 3x times x will give us 3x squared, and then 3x times negative 1 will give us negative 3x. All right, notice we have an x squared here in our equation, so that tells us we got a quadratic here. So that's going to kind of shift the way we're solving that. Before we get to that, though, let's just simplify this left side a little bit. Notice we have like terms here that we could add together. So let's see, 11x minus 8 equals 3x squared minus 3x. Okay. So I want to get everything to one side and 0 on the other. Notice I've already got my x squared term over here and it's positive, 3x squared. It's a lot easier to factor if our leading coefficient there is positive. So that tells me I want to move this stuff to the right. You didn't necessarily have to do this, but I think it's going to make it a lot easier if we move this stuff to the right. So I'm subtracting 11x and adding 8 to both sides. All right, let's take a look now and see what we have. So I have 0 equals 3x squared, negative 3x, negative 11x, that's going to give us negative 14x plus 8. So what we want to do now is try to factor this. So I know I need 3x and x. The last term is positive, middle is negative. That tells me minus minus. All right, now let's think of factors of 8 that are going to get us to a middle term of 14. Let's see, I think if we did 4 times 2, that certainly would give us a positive 8. And if we look at the outsides, 3x times negative 4 would give us negative 12x. And then inside's negative 2x, negative 12x, negative 2x certainly gives us negative 14x. So that's the correct factoring. Let's kind of come over here to finish up. So let's see, I had 0 equals 3x minus 2 times x minus 4. And now I'm trying to find the values that are going to make each of these factors 0. Let's start with the easiest one, which is x minus 4. Well, that one's easy to see. The value of 4 is going to make that factor 0 and would be one of our solutions. This 3x minus 2 is a little hard to see, so let's go ahead and write a little mini equation here. 3x minus 2, we want this factor to equal 0, so we set it equal to 0 now and we'll just solve that. So we add 2 to both sides, and so then I have 3x equals 2, divide by 3, and we see our other solution then is that x is equal to 2/3. So one final thing that we're going to have to be aware of when we're solving rational equations is that we could end up with an equation that has no solution, also an equation that has infinite solutions. Really, the rational equations are no different than any of the other equations we've studied this semester. These two cases, no solution and infinite solutions, can and will come up. So I'm going to give you a quick example here and show you kind of just to refresh your memory of what it looks like when one of these situations comes up. I'm going to take a look at one that has no solution. And I've kind of made an easy problem here. So I want to clear the denominators or clear the fractions out. So notice both my denominators are the same, y minus 2, y minus 2. So my LCD here is simply going to be just that, y minus 2. Okay, so I've rewritten the problem and simply multiplied both sides by y minus 2. On the left, I write it as a fraction because I'm dealing with fractions. On the right, I'm just going to leave it as y minus 2. There aren't any fractions over here on the right, so I'll leave it just like that. Okay, let's go ahead and distribute this now. So I'll distribute the y minus 2. Notice when I go to multiply by the first term, that y minus 2 factor is going to divide out entirely. So that all I'll be left with there is just 2y. When I multiply by the second term, again, y minus 2 is going to divide right out, and I'll be left with just minus 2. On the right side, then I'll have distribute this 2. I'd have 2y minus 4. Okay, so I have an equation. I would try to get the variable terms to one side now. So I would go to move the smaller variable term, and you recognize, oh, they're the same. This is when you need to kind of the lights need to go off and you say, oh, wait a minute, the variable terms are exactly the same, this is when we're either going to get no solution or infinite solutions. So let's go ahead and subtract and see what we get. Well, 2y minus 2y on the left side is 0, so all I'm left with here is negative 2. On the right side, all I'm left with is negative 4. When the variable terms drop out and I have an untrue statement, this is when I have no solutions. So I would say here, no solution. Now, infinite solutions is almost identical. Variable terms drop out, but when we have infinite solutions, we're left with a true statement. So had this been negative 2 equals negative 2, I would have said, this is an infinite solutions case. But since they were different, I want to write no solutions to this equation.